Hey everybody. So today we're going to be going through how to run logistic regression, and specifically binary logistic regression in SPSS, in JASP, and in R. So let's get right down to it, and we're going to start off in SPSS. So what I've done is I've preloaded this file. It is called heartdisease.sav. And what we see is we've got a bunch of different predictors, including age, sex, and this is resting blood pressure, and a bunch of different other predictors to predict heart disease, or whether a person is healthy or unhealthy in terms of heart disease. So what we want to do is to be able to give a prediction or a probability that a person will have heart disease based on one or more of these predictors. So we'll start off by going up to Analyze and down to Regression, and below this we have Binary Logistic Regression. We're going to select that. And that will open up this window. So the first thing we're going to do is select our dependent measure. And remember, I told you that that is this last one here, heart disease. We'll put that into the dependent measure. And we can do this in a block-wise way. So the first one we're going to do is just look at the impact of resting blood pressure and enter that. Then we're going to do a hierarchical analysis where we also use blood pressure and sex. Now we can go through all of the different possible categories and all the different predictors, but we'll just start with those two at this point. So I can click on categorical, and it just basically says that we've got categorical covariates, and that's sex. And test is not. Test or rest BPS is not. So I hit continue. I can click on options and see if I want any of these different options at this point, but I'm not going to. So all we need to do at this point is click on OK and see our output. I'm going to maximize that. So we're going to start off by looking down at our blocks here. And what we see is block method 1. This is where we included T rest blood pressure. What we see is we end up with beta coefficients here of negative 2.494, and we also have a beta coefficient of 0.018. Now, both of these are significant. So in order to make any particular prediction about the level of resting blood pressure and how it relates to probability of heart disease, we would want to take the constant plus blood pressure times 0.018, determine that outcome, and transform that output into probability by using the equation right here. Okay, now if we look down to block method 2, or block 2, we see that we had two predictors, and these include rest blood pressure and sex. So what we do is we say, we have our constant, then we have our rest blood pressure. So we have our equation will be our intercept plus blood pressure times 0.022 plus another impact for the sex of the participant. Now in this case, SPSS uses the last category as the reference category. And in alphabetical terms, that would be the M. So what that means is we have a minus 1.380 for change in sex. So what that means is that decreases the probability of heart disease for females. And then once we get that out, again, we can use that output to calculate the probability for any combination of those two factors Okay, so let's move on and let's do the same thing in JASP. So I'm going to load up the file that's called heartdisease.csv. Okay, we see the same data that we just had in SPSS. The way we run the model here is we go to regression and down to logistic regression. We're going to select that. Now, in dependent variable, we're going to put heart disease. And in this case, we're going to select a covariate of T-rest BPS. That's our blood pressure. Now, what we see is we get out our deviance and our AIC and BIC in the model. This just tells us about the quality of our model. A lower AIC is better, and that suggests that our model that we've put in with T-rest BPS is just better than nothing. So we see that that is lower. 406 is less than 411. We see that rest blood pressure gives us an estimate of 0.018 and our intercept of 2.494, negative 2.494. And again, we can put that into our equation to be able to determine any potential probability of having heart disease at any resting blood pressure. Now, if I want to also add in sex as also another covariate, I need to put that one into factors down here because it's categorical in this case. So if I select that and put it into factor, we see it updates the model. We see that my AIC has gone down to 382. So that's a better model. We can see that both sex and blood pressure are significant predictors in this model. And again, we can use our equation, our regression equation. So intercept plus blood pressure times 0.022 plus, in this case, sex. And this increases, if you're a male, by 1.380 from the intercept. So this is a little bit different from SPSS in that it's using female as the reference category. Now that increases by 1.380 if you're male. Then we can plug that in and figure out any probability for any combination of these variables. So another thing I may want to do is select statistics, and I can select a few different other possible options here. Sometimes we want to look at case-wise diagnostics. I click on those standardized residuals greater than 3. I've got none. Cook's distance greater than 1. It doesn't appear I have any. So the case-wise diagnostics show that we seem to have not violated any of these assumptions in terms of leverage. If I want to look at my confusion matrix, this just gives me the raw counts of the predicted versus observed healthy and unhealthy. So this will give me some kind of way I can see how good my model was at actually predicting versus reality. Okay, so let's move on and do this same analysis in R. So if I open up RStudio, we see I've got my list of commands that we've built up over time so far, and I'm going to create a new set. So I'm going to copy this section, put it down below, give a header called logistic. Drop that in. Now we don't need any special packages for this type of analysis, but what we are going to use is a function that you can actually download from a website. And what it does is it allows you to quickly calculate the probability from the logit or from the log of the odds. So what we're going to use for that is this command right here. So I'm just going to paste it and then talk you through it. So we use the command source, and then we need to put in the website name. And it's https sebastiansauer.github.io/rcode/logit2prob.r. And those need to be in quotes. And then when we run that command, we get a new object called logit2prob function. And if I look at that function, we can see what it's doing is it's just taking our odds and dividing it by 1 plus odds and outputting the probability. So what it does is it just makes our life a little bit easier in terms of doing that calculation. So the next thing we're going to need to do is load up our data set. So I'm going to first of all import a data set from text, and it's going to be the same as we used in JASP, and that's heartdisease.csv. And I'm just going to call it heart disease. In fact, let's make my life easier to minimize spelling mistakes, hd.data. And it's got headers, and it looks like everything is okay here. So I'm going to click on import. Now, one thing I may need to do is look at the structure of this data. We need to make sure the variables are correctly identified as factors. So I'm going to use the function str, or structure, of hd.data. And what we see is we've got some of these variables that are categorized as character variables and some as integers. And we're only going to be using T resting blood pressure as an integer. That's fine. We're going to be using sex, and that's currently a character variable. We want that to be a factor. And then heart disease is also a character variable, and we need that to be a factor. So we're just going to convert those into factors really quickly. And remember, the way we do that is we take hd.data, and I'm going to use column sex, and into that I'm going to put hd.data $sex, but I need to put in front of that as dot factor. And I hit enter, and then I'm also going to do that for HD. So if I just copy that, instead of sex, I use HD, column HD, and again here, HD, and run that command. If I run this structure again, we should see that now sex is a factor with 2 levels, and heart disease is a factor with 2 levels, healthy and unhealthy. So now that we've got our data in, I can import that into a data frame for each of our analyses here. So our data frame is going to include hd.data. Then we're going to attach the data frame, and then we just need to create the model. So let's call this logistic.model. Now, into that, what we're going to do is use the command glm, or generalized linear model. And the structure is basically the same as what we've seen for all the different linear models that we've done before. So we want to estimate or predict heart disease as a function of T rest BPS. So that's our blood pressure resting. We have to identify what the data is. So data equals hd.data. And then we also have to identify family. Family equals, quote, binomial. Okay, so that should create us our logistic model, and then we can print out a summary of that model. So let's just run those commands to start. So what we see is it created our new model, and it is called logistic.model. Oh, it's right there, logistic.model. But what we see here is we've got our coefficients. So our coefficients give us our estimate of our intercept here, which is negative 2.494, and our impact of blood pressure, which is 0.017, and that's 0.017 log odds increase with each increase in resting blood pressure from negative 2.49 log odds. Now, we also have an AIC, and that's given to us as 406.88, and that's the same thing we saw in the other programs. Okay, so far so good. What we've got is a couple of different estimates of our beta coefficients for a logistic model that we can then use to calculate the probability at any given blood pressure level. So the way we're going to do that is we're going to use our log it to probability. So let's say we wanted to do this calculation. We need to supply to this log it to prob, we need to give it an intercept and a slope. So we need to get the coefficients out from this model and put them into intercept and slope. So why don't we just make a new variable called intercept, or a new object that contains logistic.model coefficient, and I need the square brackets 1. And then I want to do the same thing, but for the slope. And it's just going to be coefficient 2, and I'm just going to call this slope. Then I'm just going to use my log it to prob function. I'm going to take the logistic regression equation output and calculate a probability from that. So if I say I want to use intercept plus slope times, if we estimate maybe blood pressure starting at something low, 80, might be really low. And now let's output a bunch of different possibilities. So 80, what happens if we have it at 100, 120, 140, 160, and 180? Now, if I run all of this, I should get my commands out, but I should also now get estimates of the probability of having heart disease as heart or resting blood pressure increases. And of course, I've made a spelling error, so I'm going to change that to log it to prob. I'm notorious for making these spelling errors. So let's run those again. So if we run those commands again, now we see that I have a 25% probability if my blood pressure is 80, 32% probability if my blood pressure is 100, and that keeps going up as my blood pressure increases. Okay, now if we want to add a second model that includes sex, all I really need to do is take this command, copy and paste it, and I'll just call it logistic model 2. This time it's going to be heart disease as a function of resting blood pressure plus sex. Now I've got logistic model 2. And then we're going to take a summary of logistic model 2. So, in this case, I'm going to leave this alone. I'm going to just detach at this point. And what I'm going to do is run that. Now what we see is we get new coefficients. So we've got an intercept of negative 4.03. And now with change from sex from female to male, remember R does this in an alphabetical order, we see there's an increase of 1.379 log odds. And with each increase in resting blood pressure, there is an increase in 0.022 log odds. We also see that our AIC has decreased now to 382, which suggests this is a better model. Indeed, both of the predictors are significant. So 0.002 for blood pressure and 9.89 times 10 to the negative 7 for sex. Now, if we wanted to run this same equation, all we need to do is add another term, slope 2 in this case, and we need to just add that for sex. And that would be the other coefficient that would be put out from the model. So, hope that gives you a good understanding of how we do logistic regression in SPSS and JASP and R. There are a lot more details that you can get into, but I wanted to give you the basics on how you run these analyses.